Hi everyone, my name is Jada Carter, and for my Genius Hour project, I chose to study biofertilizers. Biofertilizers are defined as substances which contain living microorganisms that, when applied to a plant, promote growth by increasing the supply or availability of primary nutrients. The most radical idea currently being explored in agriculture right now is the use of these biofertilizers to mitigate the adverse effects of commercial synthetic fertilizers on the health of airways, waterways, and soils. With the human population rapidly expanding, there was an initial need to create these synthetic fertilizers so that crop production could increase. And now we're seeing that misuse of fertilizers and overuse of fertilizers has become rampant and created some of the major environmental and socioeconomic issues that we see today. So my question is, what advantages do biofertilizers confer over our synthetic fertilizers that we use today? So first, it's important to note that synthetic fertilizers, specifically nitrogenous fertilizers, are created using the Haber-Bosch method of fertilizer production. The Haber-Bosch process takes inert, non-biologically active nitrogen in the form of N2 and creates it to a biologically active form in ammonia. Some other nitrogenous fertilizers include urea, anhydrous ammonium nitrate, and sodium nitrate as well. The issue with this process, however, is that it emits a lot of greenhouse gases, obviously contributing to climate change. Agricultural runoff is a big issue post-production. So when these fertilizers are used, they will run out of the plot of land into a neighboring stream and cause downstream negative effects such as eutrophication. And over-fertilization is becoming an issue as well. Farmers are over-treating the plants thinking that it's helping, and really it's not. The plants are only going to take up as much nitrogen as they can. The rest of it is just going to disperse into the soil and eventually either become runoff or contribute to soil acidification. But the important thing to note is that biofertilizers can do this process on their own. Specifically, we're looking at mycorrhizae fungi. Mycorrhizae fungi can do the same process of taking inert N2 and changing it into something biologically active in the form of ammonium. So this image just describes the difference between a non-mycorrhizal plant and a mycorrhizal plant. A mycorrhizal plant has improved expression of genes involved in nutrient uptake and water uptake. The plant will have a higher resulting biomass and be able to expel harmful salts such as sodium and chloride out of its system more easily, and it can maintain ion homeostasis much more efficiently. This is all due to enzymes. So the biochemistry in this is that these mycorrhizae fungi and some termites are the only organisms in the world to produce this nitrogenase enzyme that's responsible for the conversion of N2 to NH4. This is extremely important. They are the way that nitrogen is cycled throughout our system, throughout the closed system of Earth. The intellectual merit of this project is that selecting microorganisms for symbiosis is an exact science. However, researchers have yet to find a species or combination of species for every crop produced. The broader impacts of this project include mitigating the harmful use of fertilizers, which are harmful for the consumer, they're harmful for any farm workers who might be applying the fertilizer, and they're harmful for anything downstream of the farm. They reduce greenhouse gas emissions from manufacturing, both in the form of reducing N2O as well as CO2, and they reintroduce the evolutionary relationship between fungi and plants that's already been established over time. And finally, reduces the harmful runoff from fertilizer overuse that causes eutrophication and spoils nearby waterways. Thank you for listening, and here are my references.